All right, so if we have new formulas for derivatives, then we get new formulas for antiderivatives too, right?
Way too much.
Johanna, you're missing out on some cookies today.
So is this no carbs or what?
Yeah, you could go no carb with this. So the antiderivative of 1 over the square root of 1 minus x squared is obviously inverse sine, because the derivative of inverse sine is that. And the antiderivative of
What? Need to change.
1 over x squared plus 1 dx. Bless you, inverse tangent.
Where do you have that written down on our paper?
Yeah, we're going the other way now. Do an antiderivative.
So why would
No,
you
but
write this down?
saying we already have this.
Yeah, you don't necessarily have to write it down. You can just translate it the other way around. Okay? That's fine. We don't have to know.
Watch my neck.
What?
One you ever done?
No, I don't do it.
Okay, so let's do a couple.
Great.
With our newfound knowledge. Let's do the integral from 0. Okay, any questions? All right, we're done learning. Good work. Okay, let's do the integral from 0 to 1/4 of 1 over the square root of 1 minus 4x squared. What does that look like to you?
Sine. A bunch of crap.
The inverse, yeah, bunch of crap. Good call. The inverse sine thing, right?
Oh, yeah.
Right? But we've got a 4x squared in there instead of an x squared. So we're going to make a u substitution.
Oh, no.
Oh, yes, we did. And it gets worse. No, it gets worse. Hold on. Because in the antiderivative formula, it's not 1 minus x, it's 1 minus x squared, right? So we need to figure out what u squared is.
What?
So u squared is going to be what?
Why would you know what?
All right, let's not figure out what u squared is. You tell me what u is then, and I'll tell you why that's not going to work.
1 minus 4 squared.
No. No.
4x squared.
No.
1 minus 4x squared. Quantity.
No.
And a half. I don't know.
No.
4x squared.
Okay, as soon as you put an x squared in your u, okay, I don't care whether it's 1 minus 4x squared or whether it's just 4x squared or whether it's the square root of 1 minus 4x squared, those are all suggestions that you guys made. As soon as you put an x squared in there, when you take the derivative of that, you have 2x dx, right? And we have a dx over here, but we don't have another x. So I can't do this with my u substitution being anything squared, okay? So it has to be just a plain old something times x, okay? Are you ready?
Yeah, but what if we use u squared?
Right, that's where we're getting to. So it's going to be u equals 2x, okay? Because, watch, wait. U is going to be 2x. Now du is just 2 dx. So I have the dx here, and I can just do that 1/2 thing. But this isn't 2x, it's 4x squared. But conveniently, u squared equals 4x squared. Okay? So now I can rewrite this as 1 over the square root of 1 minus u squared, right? Right? Because if u is 2x, then u squared is going to be 4x squared, yes? Okay? So I kind of use this to get to that, which is what I really wanted. And then I need to change this dx into a du. So you've done this a million times before. That means dx is going to be du over 2. So I'm going to change this dx right here into a du over 2. Okay? Totally awesome. Okay, and then I'm going to do that little game so I don't have to substitute back in. I'm going to change my limits of integration using this thing right here. So 0 is really now what? 0 because 2 times 0 is still 0, and 1/4 is now 1/2 because 2 times 1/4 is 1/2. So antiderivative of 1 over the square root of 1 minus u squared is easy. It is?
That's a lot.
Nope. You can't be serious.
Oh,
What?
I'm so
Yeah, inverse sine. So this is going to be 1/2. Whoops, and then I write this.
Ah,
Your fault. Inverse sine of u. And we're going from 1/2 to 0. Okay?
How do we put an inverse sign back up there?
Well, that's why we just did that whole thing that we were doing. So this is going to be 1/2 of the inverse sine of 1/2 minus the inverse sine of 0. Okay? And we just did this. So what's the inverse sine of 1/2?
0.5.
Which is what, 5 or 6?
Looks like 5, 5 or 6.
Yes, okay.
3.
So this is going to be 1/2 pi over 6 minus the inverse sine of 0 is going to be just 0, right? And so the final answer is pi over 12. Okay?
How'd you get 5 or 6 for finding the 1/2?
He did it on the calculator, but what I really was hoping you guys would do is just think about what we had just been doing. Inverse sine of 1/2.
You like to use our reasons.
I know you do, Mr. Weaver. You do opposite over hypotenuse. Yeah, so that means the opposite is 1. The hypotenuse is 2. So this is a 30, 60, 90. So that means, yeah, that's root 3. This is the short leg. So that means this angle is 30 degrees, and 30 degrees in radians is pi over 6. Right. Okay? So that's how you get that. All right, I'm going to do one more here that you're just really going to be unhappy with, but really this is, I think, kind of just for Tyson, because he's my Y guy. So we're going to do a little problem here, and in the end we're going to get a formula. Okay, so now I'm doing a general form, x squared plus a squared, to see if I can get something out of that. And then we're going to use that to come up with another antiderivative formula out of this. Okay, so by doing x squared plus a squared, we're looking at a general case of this. And then we'll be able in the future to use whatever number we want for a with facility. Okay, are you ready? Yes, Mr. Aldrich, we are ready. All right, so what I'm going to do with this, and you just can like close your eyes and go to your happy place if you want for a little while. I'm going to, you already there, Nate?
So like that's you know.
I'm going to factor out, no, you're not supposed to do that. Okay, I'm going to factor out an a squared from the bottom. Okay, with me? All right, so since this is just a constant, what I've done is I've changed this integral to 1 over a squared times the antiderivative of a squared, or x squared over a squared plus 1 dx, right? So I can pull that out, just like I can pull out the 1/2 from the other problem, okay? So now just like we did before, I'm going to make a u substitution. Any guesses? What? Go to the back of the class. Okay. No, my u substitution is going to be x over a. Oh, it's in the book. Okay. So then that means that u squared is x squared over a squared. So I can now change this to 1 over u squared plus 1. Okay. What's the derivative of x over a?
1 over a.
1 over a dx, right? Yeah, 1 over a dx, okay? So that means since I want to substitute in for dx here, to solve this for dx, I have to multiply both sides by a. So dx is equal to, just go to your happy place, think about that last cookie. That means dx is a du, right? So my du goes right here, the dx becomes the du, and then the a is going to come here on the outside. The a on top and the a squared on the bottom are going to cancel, so that gives me 1 over a. Okay? And then now we have it through an easy form. What's the antiderivative of 1 over x squared plus 1? Arctangent. So my answer here is going to be 1 over a times the arctangent of u, but u was x over a plus c. Okay? So this is something, now you guys should come back down to planet Earth.
What?
Back.
So what we just did is we came up with a general formula for the antiderivative of 1 over x squared plus a squared. And that is, yeah, go ahead. 1 over a times the inverse tangent of x over a plus c.
I had a question on the last
What, the one that we finished or the one that we were just doing? Okay. When I take the derivative of x over a. Okay, I'm thinking of this as 1 over a times x. So 1 over a is just a number like 5. So the derivative of 5x is 5 dx, right? Yeah, it's just a constant.
Look.
So the derivative of this is just going to be 1 over a dx. Okay? Okay, so now that we have that, we can use it to do problems like this. You guys are back with me now, right? Zach? Boom. Boom. Whoops. Oh, yeah, that's right. Okay, so let's find the derivative of x over x to the fourth plus 9 dx. So we're going to make a u substitution again. What's u going to be? X squared, very nice. Okay, and that's okay this time because now when we take the derivative of that, you're going to get an x in there, right? But they gave us this extra x on top to work with just so that would work out. So the derivative of x squared is 2x dx. Yeah. So this x dx right here really equals du over 2. So I can rewrite this as 1/2 du over, if u is x squared, x to the fourth is u squared, right? And we'll all speak at once. And then I can think about 9 as being 3 squared. Okay? So now if I use this formula right here, it's going to be 1 over a, so it'll be 1 over 3. But I already had a 1/2 there, so that's going to make it 1 over 6. And the inverse tangent of x over a, which is x over 3 plus c. Right? Oh, no, because we have u, that would be u over 3. But u is x squared, so it should be x squared. Okay?
Zach pulled up.
I got it.
Are we reading it right now?
No, but
Death of most solid is not. Yeah, what?
Here what?
How do they prove that at all?
it's a sacrificial killing.
Same as Hitler.
His name is Hitler?
They did enough.
You guys,
it came to a point where, all right.
what you guys kind of have going here is this Life of Pi thing. You probably didn't see that when you did it.
Is
I
it
want to
good
see
luck?
it.
It is a good movie, yeah.
Tiger.